In this first part of the Git demo, we will cover the basics of Git. So for example, how to introduce yourself to Git, how to create a repository, how to commit changes and get changes from the repository, and so on. So after you install Git, you should have the Git tool available on the command line. So you can run the command Git. And if you just execute Git, you will get the usage information for Git with the most commonly used Git commands. And to find information on any command, you can simply type git help and the name of the command. For example, let's try to write git help init, and that brings up the Git manual page for git init, which describes the command, the synopsis, and so on. Now let's get started with using Git by introducing ourselves to Git, which is the first thing we need to do. To do that, we use the git config command. In particular, we're going to write the git config -- global user.name, which means that we are telling it our username. We'll specify our username, which in this case is George P. Bordell. And you can also provide your email address in the same way. So you still use the git config -- global command, but in this case, you will write user.email as the property, and then you'll specify a suitable email address. In this case, the email address of George P. Bordell. We will now look at some commonly used commands to create and maintain a local repository. Let's first create a new project and call it my project. So to do that, we are simply going to create a directory. Then we're going to move into that directory. Now, if we try to call the git status command at this point to see what's the state of my project, of course, Git doesn't know anything about this project, right? So you will get an error. It will tell you that basically we are not in a Git repository. So how do we create a Git repository? How do we make this a Git repository? Well, we do it by calling git init. And the output will tell you that the repository was initialized. If we check the status again, you will see that now Git recognizes the repository. And it will tell you that there's nothing to commit because, of course, the repository is completely empty. So let's just create a new empty file, which we're going to call readme. So now if you run git status, as you can see, Git will tell you that there is a file that's called readme, but it's untracked. And what that means is that the file is not staged, if you remember our lesson. So what we need to do, we first need to tell Git that, this file needs to be considered. And the way we do that is by calling the git add command. And then we specify readme as the argument for the command. If we call again git status, now as you can see, Git knows that there is a new file called readme because the file is staged. So Git is aware of the fact that this file has to be committed. So to commit the file, we simply execute git commit, which will open a text editor, which can be different depending on what is your environment. And here we need to add a comment to be added to the commit. So here we're simply writing added readme file. Then we can close and save. And this will add the file to the Git repository, the local Git repository, of course. So at this point, if we run git status again to see where we are, you can see that Git tells you that there is nothing to commit because, of course, the only file that we have is committed to the repository. Now let's make some changes to our readme file. I'm just going to add some text here. Once more, we can run git status. And at this point, Git knows about this file. So it will know that readme file has been modified. Remember that before it was telling you that it was a new file. Now it knows that there is a different version in the repository. So something we can do at this point, for example, is to check the differences between this file and the committed one by executing git diff readme. And if we look at the output of the git diff command here, you can see that this line, readme file content, was added. And you will see that it's added because there is a plus sign before that line. In case of deletion of lines, you will see a minus sign there. So at this point, if we want to commit our file, remember that we'll always have to tell Git that we want to stage the file before committing it. Otherwise, it will be ignored by the commit operation. So to tell Git that the file has to be staged, we can use the usual git add command. But if you remember the lesson, we can also use a shortcut. So we don't really have to do this in 2 steps. We can simply say git commit -a, and this will tell Git to commit all of the files that Git knows about, which in this case is only the readme file, of course. Something else that we can do is that we can also provide right away a message for the commit without having to open an editor. So to do that, we can specify the -m option. And at this point, we can just put in double quotes our content. We press enter. And as you can see, Git will notify us that one file was changed. And in particular, will also tell you that there was an insertion. Again, if we run git status, because you will see that there is nothing else to commit. So now let's imagine that you want to see the version history for your repository. You can do that by running the git log command. So if you run that, it will show you all the different commits for your repository, and each commit has got a commit ID, as you can see here. And the one down here is the first commit, whereas the one above is the second commit. And as you can see, it will also show you the comments associated with each commit. And in case you wanted to see the changes introduced by a commit, you can use the git show command, and you can provide the commit ID for the commit that you're interested in. And you don't really need to provide the whole ID. You can provide the first 4 or more characters. So that's what we're going to do here. So we're going to specify the second commit. And when we execute the command, it will show us the changes introduced by that commit. To fetch a repository from a remote server, you can use the git clone command. So you will write git clone and then specify the URL for the remote repository. Here we're using the SSH protocol, and there's different other protocols that can be used, so the remote repository can be made available in different ways. And as you can see, when you clone the project is cloned into the local directory. And if you wanted to import the project under a different name, you could just specify the name that you want for the local directory. For example, in this case, my project 2. And so here we will get the project in my local workspace with the name that I specified. So let's go inside one of these 2 projects that have the same content, because they're coming from the same repository. If you want to see the details of the server, you can use the git remote command and specify the flag -v. And here we will show you what is the remote repository. Now let's go ahead and make some changes to the project. For example, let's add a file. So I'm going to just create this empty file. So I'm going to call new file. I'm going to add it to my index so that it gets committed later on. And then I'm going to run git commit to actually commit it to the local repository. And I'm going to specify the comment for the commit right away here from the command line. So when I do that, the file gets added to my local repository. And if we want to double check that, we can run git log. And if you look at the last commit at the top, you can see that it's telling me that the new file was added to the repository, showing the comment that I added. But this is just for the local repository. So I need to use the git push command to push it to the remote repository. And at this point, when I run that, my local changes will be committed to the remote repository. So now let's go to the other copy of the project that we created, the one under directory my project 2. If you remember, this project was linked to the same remote project, but of course if we run git log here, we don't see this latest change that we made because we didn't synchronize this local copy with the remote copy. And so we just have these files, readme and file, that were there before. So what we need to do is that we need to pull the changes from the remote repository using git pull. And when we do that, that will actually pull these changes and therefore create the new files that we created in the other directory. And if we run git log now, you can see that now we have the new entry, the commit at the top, that says that this new file was added. And of course, this is just an example. So we had 2 copies of the project on the same machine and for the same user. So the normal usage scenario for this, it will be that each user will have their local copy. But this should have given you the idea of how Git allows you to work on some local file, commit them and push them to a remote repository, and other users to get your changes, do further changes, push them as well, and then that will allow you to get their changes, and so on and so forth. So really allows this collaboration between different users and keeping track of all the changes made by the different users. So now let's look at some more advanced concepts, which are the concept of branching and merging. So what branching means is basically to make a copy, to create a branch of the current project so that we can work on that copy independently from the other copy, from the other branch. And then we can decide whether we want to keep both branches or we want to merge them at some point. And you can, of course, have multiple branches, not just 2. And the reason why this is particularly useful is because in many cases, if you think about the way we develop software, or in general, we work with artifacts, we might have the need to create kind of a separate copy of your workspace to do some experiments, for example. So you want to change something in the code, you're not really sure it's going to work out, and you don't want to touch your main copy. So that's the perfect application for branching. If you want to do something like that, if you want to experiment or do some modification that you're not sure about, you will branch your code, you will do the changes, and then if you're happy with the changes, you will merge that branch with the original one. Or whereas if you're not happy with the changes, you will just throw away that branch. So this is just one possible use of branching, but it's one of the main uses of that. So now let's see how that can be done with Git. So first of all, if you want to see which branches are currently present in your project, you can simply execute git branch. And in this case, you can see that there's only one branch, which is called master. And the star there indicates that this is our current branch. So how do we create a new branch? So we simply run the command git branch and specify a name for the new branch. For example, we'll call it new branch to make it very explicit. At this point, if we run git branch, of course, we will have a new branch, but master will still be our current branch. So if you want to switch to the new branch, we will use the git checkout command and specify the name of the branch that we want to become our current branch. So when we run that, Git will tell us that we switched to the new branch. And if we run git branch, you'll see that now the star is next to new branch because that's our current branch. There is a shortcut for these two commands. If you run the command git checkout, specify the -b flag, and then the name of the new branch, it will do both things at the same time. It will create the new branch called testing in this case, and then it will switch to that new branch. And it will tell you after executing the command. So now if we look at the git branch output, you can see that there's 3 branches and we are currently on the testing branch. So now let's create a new file. We'll just call it test file, put some content there, save it, we add it and commit it. And as you can see, now in this current branch, we have our test file. So now let's switch to a different branch. So let's go back to the master branch using the usual git checkout command. So now if we do an ls, if we check the content of the current directory, we can see that the test file is not there because of course it's not in this branch. So now let's assume that we are happy with the test file that we created with the modification that we made on the branch. And so we want to merge that branch with our master branch. To do that, we can call the git merge command and we'll specify the branch that we want to merge with the current one. So we will specify testing in this case. That will merge the testing branch with the current branch, which is the master, which means that now the test file is in my current working directory, is in my current branch. And if I run git branch, you will see that the testing branch is obviously still there. So let's assume that we want to delete the testing branch at this point because we don't need it anymore. We could simply execute git branch -d, which stands for -delete, specify the name of the branch, and this will eliminate that branch, as confirmed by running the command git branch, where the testing branch no longer shows up. So something that might happen when you merge branches is that you might have conflicts. For example, in case you change the same file into different branches. So let's see an example of that. So we're gonna check which branches we have. So we have 2 branches in this case, master and new branch. Our current branch is master. Let's open this file called new file and add some content there. So now let's commit these changes so that they get to the local repository. Now let's switch to the other branch. And if you remember, we do this by running git checkout and the name of the branch. And at this point, we do the same operation here. So we take this file and we change it here too. In this case, we add content that reflects the fact that we are in the new branch, just for convenience. Okay, at this point, we also commit the file here. The comment here is, of course, that this is the new file in the new branch. So at this point, what we have here is that we have this file called new file that has been modified independently, both in the master branch and in the new branch. So we have a conflict, right? So now let's switch back to the master branch. So now let's say that we want to merge the 2 branches. So since we are in master, we want to say that we want to merge the new branch into the current one. And when we run that, we get an auto merging conflict. So at this point, what we can do is that we can manually fix the conflict by opening the new file. So the file that was showing the conflict. So here you can see the kind of information that you get in the conflicted file. So it's telling you basically that there is in the head, which is the master, this content, which is new file in master, which is the content that we added, of course. And then, under, this separator, you can see the content that was added in the new branch, which is the content, say, new file in new branch. So basically what this is showing you is the parts of the file that are conflicting. In this case, since we have only one line, it's basically the whole file in the 2 versions. And you can decide which version you want to keep or how you want to merge in general the 2 pieces. So here, let's assume that we want to keep the content from the master. So what we're going to do is we're going to eliminate the annotations and we're going to eliminate the additional content. We save this file. So at this point, what we need to do is simply to commit the modified file, the merge file, and we do that in the normal way. We call git add, specifying the file, so git add new file. Then we run git commit new file, and we specify in the comment for clarity that this is the merged file, so that we performed a merge. And at this point, we are done with our merge.